Shape memory polymers can be programmed to change shape when certain conditions are met. 3D printing can produce these shapes by stacking layers after layers, allowing us to make any shape imaginable. In this video, we demonstrate how we can produce stents that can be shrunk to a compact form when being delivered and recover to the most complex shape at the right moment.
By the use of this method, it is possible to design custom-tailored stents for each patient, because anything that can be designed can be exactly manufactured using the 3D printer.
Set the diameter of the proximal main vessel to 25 millimeters. Then, set the diameters of the distal main vessel and the side branch equal to 22 millimeters. Set the total length of the vessels equal to 140 millimeters. Next, set the length of the proximal main vessel to 65 millimeters, the distal main vessel to 75 millimeters, and the side branch to 65 millimeters. The computer model of the branched vessel is then printed by using a fused deposition modeling 3D printer and a polycarbonate filament. Create a box-shaped container that will house the 3D printed part. Set the container dimensions to 110 by 105 by 70 millimeters and use an acrylic plate. With the 3D printed branched vessel placed at the center of the box, gently pour the silicone inside the container to minimize bubble formation. Dry the liquid silicone and harden it for 36 to 48 hours. Once hardened, remove the solidified silicone from the container and cut it in half to remove the 3D printed part.